All right, here we go. So we're getting into the roots. So this is where things get, and rolling up my sleeves. Things are getting interesting here. All right, so solving a square root equation. How do you do it? Well, basically, it's kind of like absolute value. First step is get the root alone. We have to isolate it. And then second step, you're going to do parenthesis 2 power on both sides. I don't know if you remember, but a 2 power is the opposite of a root. And then step 3, you must check your answer. Yeah, do you remember that?
Right, 2 power equals 2 power.
That's what we're going to do. That's the action we're going to take. We're going to do that on both sides. That's the action on step 2.
Okay.
Yeah. And now why? Let's make sure we're clear on that. What if I had like square root of, 7 or whatever, okay? And then I put a 2 power on it. What would happen?
It would be 7.
It would be regular 7, right? We all get what? Well, because it would be 2 root 7s. And, and there's a couple ways you can do it from there. You could say, well, that's root of 49, right? 7 times 7 is 49. And what's the root of 49? Plain 7. So see how it canceled? Or you could just say, you want to skip a step, you could just say, look, 2 7s inside, 1 7 outside. Either way, the answer is regular 7. So in other words, what happened is this root and this 2 power canceled each other out, don't they? They're opposites. It's like a poison and an antidote, right? You swallow the poison, you're supposed to swallow the antidote. They neutralize in your stomach. That's what the 2 and the root are doing. They cancel each other out. They're opposites. All right. That's why when we see a root, we should think, oh, I'm going to 2 power both sides, and that's going to get rid of that root. That is the game plan. All right. So let's do it. That'll tear off the shell. Pull the snail right out. All right. So first step is to get the root alone. Well, it already is alone. It's already by itself. So there's nothing really to do there. So I can just come on right on down here and just go x minus 6, 1. And then I'll just do step 2, which is parenthesis 2 power to the left. But if you do that on the left, you have no choice. You've got to do the same thing to the right. You've got to keep the balance, right? If they were equal before, you treat them the same, still be equal. Okay. And then the root and the 2 power cancel because they're opposites like we just talked about. And so that gets rid of it. And then what's the other side? What's 1 squared?
1.
Yeah, 1 times 1 is just 1, huh? Now we got rid of the root. See how we got the root out of there? We got to pull the snail out. So now we can just solve. Just add the 6. X is 7.
Okay, so the last one was put the house when you put it over the front house.
Yeah, I got it.
This one is pull the snail out.
Yeah, there's almost too many analogies, huh? All right, we good on that one? That makes sense?
Yes.
So you can put this game plan right on your 3x5 card. Whenever you got a root question, that's what you do. All right, let's look at number 9. Number 9 is a word problem, so I want you to see the words. There it is. There's number 9. So to estimate, they give the formula a little bigger. It's kind of a fun one. I like being real every now and then, but see some of the real life uses of this stuff. Okay, so it says to estimate, police use this formula to estimate the speed of a car, v in miles per hour, it's velocity, miles per hour, based on the length L in feet of its skid marks when suddenly braking on a dry asphalt road. At the scene of an accident, a police officer measures a car's skid marks to be 209 feet long. So he measures them to be 209 feet long. Approximately how fast was the car traveling? Round your answer to 1 decimal place. Okay. Well, it's really not a hard problem. It's really just to plug in and use the calculator. Let me show you. So they're saying to us right here, the car's skid marks were 209 feet long. So that 209, it's either V or it's L. Which one is it? Is it V or is it L? Yeah, it's L, huh? Because they say L is the length in feet of the skid marks. So that 209 plugs in right there for L, doesn't it? So then just use your calculator. So what do we got? We got V equals the square root of 20 times 209. So you know how to get the square root in your calculator and crank that out? So 64.65. But they say round to 1 decimal, or the tenths place. 1 place. So remember how to round. You circle the spot you're going to stop at. We're going to stop 1 decimal place. And you look 1 to the right. And if the one to the right's 5 or more, you go up, huh? So it'd be 64.7. 64 points. So that car must have been going 64.7 miles an hour. So, and they ask us want us to solve for x. How do we, what do you do when you got a right triangle? Anybody remember how to do that one? Yeah, the a squared plus b squared is c squared. Called the Pythagorean Theorem. Right, for right triangles. A squared plus b squared. Now, when you use the Pythagorean Theorem, so A and B, you can switch the order, doesn't matter at all. C, you got to make sure you get C to be the correct one. C has to be it's called the hypotenuse. It's got to be the longest side. Because see how they add up to be C? They squared, add up to be C squared. So C has to be the longest side. So which side is, by looking at it, can you tell which side's got to be the longest? 17. This has got to be C, doesn't it? That's the longest side. It's called the hypotenuse. It's the side opposite the right angle. It's the longest side. Yeah, so that's got to be the 17. And then the other two, it doesn't matter what order. The A and the B, you can switch them. It doesn't really matter. But make sure you get the C correct. Okay. Let's crank it. X squared, 9 squared, 81, 17 squared. Is it like 289 or something?
Yeah,
There's 289. Okay, choose your calculator there. So how do we solve for x? X is saying, I want to be alone. What do we do first? Subtract that 81, right? Get rid of that 81. And that's going to be 208. Now, we're good so far? Now, how can we get like just normal x? That's what we want, right? Just normal, regular x. Yeah, good thinking. I'm glad the way you guys are thinking. Roots and 2 powers are opposites, aren't they? You getting the hang of that? So, if you got something like, let's prove it real quick. What if we had 3 squared and we put a root over it? What would that equal? Yeah, just 3. You can tell because it's root of 9, right? 3 squared is 9. And what's that? 3. So you can tell they just cancel, and the answer is just 3. Yeah, so again, either order, if the square's on the outside or the square's on the inside, the root's on the outside, either way, when they get together, they eliminate each other. So it's kind of always our game plan. If we see a 2, we think, oh, root it. If we see a root, we think, oh, 2 it, or 2 power it, it's called. But yeah, that's the game plan. They're opposites of each other. So they undo each other. Yeah, so that's what we'll do. That's why, by the way, that's why it's called a square root. You ever thought about that? You ever stayed up late at night and thought, why do they call that a square root? Where's the square? Right? We call that a square root. Why are we saying, why don't we just say root? Why are we saying square root? You haven't stayed up late at night and thought about that? Had trouble going to sleep because you don't know why that's called square root? That's just what weird math teachers do. I know. So why is it called, does anybody know why it's called a square root? What's this called? X2'd? Squared. What's this called? X3'd? Cubed. So square is a word for what? 2. And cube's a word for 3. So when we call this a square root, what are we calling it? A 2 root. Where's the 2? 2 for 1 deal. You see? I'm not making stuff up. We've been calling it that all along. It's a square root. It's a 2 root. That's why it's a 2 for 1 deal. Guess what you do if you have a 3 in the hook? Third root, guess what deal that is? 3 for 1, obviously, right? So that's I'm just trying to more deeply sink in your mind. That's, of course, the deal. It's got it in its very name. It's got 2 in it. It's a square root. So, of course, you use it when you have 2 of something. So, all right, so that's why it cancels out a 2. Because it is itself a square root, a 2-rooter. It undoes a 2. All right, so we just get plain x. Now, on the other side, we have to simplify. Remember about all that? 2, you got to break it down. They don't want a decimal here. They specifically say, no decimal, please. Just simplify your root. So that's going to be, what, 104, and then do it again. 2 times 52, do it again. 2 times 26, do it again. 2 times 13, look at all that. So what do we got? 2, 2, 2, 2, 13. So the root of 208 becomes 1, 2, 3, 4, 4 2s and a 13. That's the pieces of a 208, huh? And then remember what it is? It's a square root, so it's a 2 root. 2 for 1 deal. 2 2's in, 1 2 out. 2 2's in, 1 2 out, and they times. 2 times 2, 4. What's left inside? 13. There it is. 4 root 13. Is that good? Do you like the way math just all makes sense and works out? It just takes time to get there to understand all that it's saying, but it is logical. Number 11. Here we go. Some of these get a little challenging. We can do them. Just got to make it through all the mess. Okay. All right, so again, when you see square root, what are you thinking is your plan? What's going to get rid of that root? We got to get rid of that thing. Because you know what X is saying. X is saying what he's always saying. I want to be alone. So get rid of this negative 9. Get rid of this root. Get rid of this 18 so I can be alone. So what are we going to do? What's the major thing we're going to do to get rid of that root? We're going to 2-power it eventually. But first we have to isolate it. Yeah. Exactly. So first step, get the root alone. We do this kind of thing a lot, huh? We get an absolute value alone, we get a root alone, we get alone whatever we're trying to take care of. So
when it comes to these don't necessarily have to be like the other side. The only way you can put that formula in is you had to make sure the right was 0.
Oh yeah, that was a little different. Yeah, these you don't have to get 0. Yeah, that was x squared. Excuse me. That was x squared and x to the first.
Right.
If you have both those together, you've got to start with 0. That's right. That was
on a certain side, so you can do the A, B, C.
Either side, you just have to have 0 on one of the sides. Yeah.
But that was the big fight I was having there.
Yeah, you had to get 0 for those kind, right? Whereas these are different. These we don't want 0. We want to isolate the root. Exactly. You're getting it. You're getting it, Dennis. Good. All right. So now we isolated it, and then step 2, parenthesis 2 power, parenthesis 2 power, right? Because that's the opposite. So we go parenthesis 2 power. Do the same thing to both sides, and the root cancels the square. They're opposites. All right, so then we get x minus 18. Calculator there, 256. Thank you. And then last step, x is, we got rid of the root. We did the major thing. Root's out of there, but the 2 power. Add the 18. So that puts x alone, and that gives us, there it is. Thank you. 274. Back to number 12 is a word problem. This will be another easy one. V equals square root of 2.4r. It says this is the formula for the maximum safe speed v, velocity again, in miles per hour, at which a car can travel on a curved road with radius of curvature r in feet. Do you get it? In other words, depending on how sharp the curve is, this is the speed, the velocity you can travel at and not slide off the road, at least for typical tires on a typical surface. Kind of neat little physics relationships here, huh? Velocity and curvature, right? So in other words, what they're saying is, if you have a circle, right? Suppose you're driving your car around a circle. It's got a radius r. Radius is from the middle to the edge of a circle, right? And if you're cruising, here we go. Here's Mr. Heron in his family van. That looks like a rocket. That looks like one of those cartoons. Yeah, my artistic skills are very challenged. I don't know how to make a van. Anyway, there I am. So if I'm going around that corner in my family van,
you're not drifting.
Right. Hopefully not. Can I go faster on a circle like that, or what if I have like a smaller circle with a tinier radius and my family van? What do you think? Which one do I have to go slower on? Smaller circle, because it's tighter. It's tighter turning. You can't go as fast, right? Smaller radius, you have to go lower speed. Makes sense. If we plug in a smaller r here, we're going to get a smaller v, aren't we? Just showing you it's a connection between velocity and radius of curvature so you don't slide off the road. Okay. So anyway, enough fooling around. What's their question? Their question is, right over here, I'm kind of concealing it. 740 feet. Yeah, so if you have a radius, they're saying, of 740 feet. So what they do is, this is what highway people would do. They would have a little piece of curvature of a road. They would finish the circle. They have instruments that will finish the circle. And then they'd measure the radius of that circle. I didn't finish that circle too well, but you get the idea. From a little piece of a curvature, they can actually complete a circle, measure a radius, plug the radius into this formula. Now, in reality, if you're thinking, come on, really, Mr. Heron, you tell me those road guys are out there doing that?
Oh, no, somebody else did that.
Yeah, and didn't they use software to do it?
Yes, they did.
Absolutely. So, but hold on. This is where it's often so. The road operator would use technology and plug in the 740. So let's crank that out. Let's crank out that little 740 there. So use your calculator. It's going to be the square root of 2.4 times 740. Hit the buttons. Maybe you've already. That's what I'm getting to. They want me to round somewhere, don't they? 42.4. Yeah, they say round down. Whole number. Did it say a whole number? Yeah. So 42 miles an hour. So the safest speed would be 42 miles an hour. 42 miles an hour. And there it is. We good with that? So those are just plug in. Those would be super easy for you. Let's go to the big 13.
So they're all the same type of plug-in thing.
Yeah, just plug them in and hit the buttons. Yeah. So not bad. Let's go to 13. 3 plus 2 square root x plus 6.
So all formula.
So step 1, get the root alone. So get the root alone. It's multiplied, right? It's nothing between it and the root, so it's times. Whenever there's two things with no symbol between, they're always multiplied. So this is 2 times the root.
Thank you.
Uh-huh.
So maybe I should start writing.
Sure, that couldn't hurt. What's our first step to get the root alone?
Take the 3 over.
Yeah, get rid of that 3, huh? Boom. Yeah, we're going to divide the 2 because it's times, huh? Like we were talking about. Good. Divide the 2. Boom. All right, we isolated. That's all step 1. We got the root alone, huh? Now, step 2. You know what to do. Let me let you finish it. So we go parenthesis 2 power, parenthesis 2 power, huh? Because that's the opposite of a root. And so it cancels it out. That side's 9. And last step, x wants to be alone. Subtract 6. After all that work, x is 3. Let me remind you of 2, because there's going to be 2 things in this one. So first off, you know the game plan for roots, right? You get it. So the root plan is basically, get it alone and then 2 power both sides. Well, let me write the get it alone. Yeah. So root alone, this is the root plan, and then 2 power both sides because 2 power is the opposite of a root. You know that. Okay. Secondly, what's the plan? Let me remind you, it's exactly what Dennis was talking about. Remember the x squared and x to the first part? If that ever shows up, you know it's coming in this problem, or I wouldn't be talking about it right now. In a minute, this is going to rear its ugly head all of a sudden. When it shows up in a minute, halfway through the problem, all of a sudden, there it is, x squared and x to the first. And what do we do when we say, what do we do in the whole last night's homework? When we see x squared and x to the first, what do we do first? Get a 0. First we get a 0, don't we? First we get a 0, and then we can try to factor, if you want, with 2 parentheses, and each one equals 0, or you can do the negative b plus or minus the square root of b squared minus 4ac.
Over 2a.
All right, you guys have been practicing this. Yeah. So I want to remind you of those 2 because we're going to need to execute both plans in this one. There's going to be both a root situation, that's right now, and then halfway through, all of a sudden, x squared and x to the first, and we're going to go to a whole new game plan. Does that make sense? All right, go for it. See if you can make it happen.
I thought you did.
So we have to go parenthesis 2 power, parenthesis 2 power. Right? See how I'm doing the parentheses? You have to, you can't, by the way, you can't go just that squared and that squared like that. That isn't true and won't work. You got to do parenthesis 2 power, parenthesis 2 power. Right? And then you know what happens. The root and the 2 power cancel. They're opposites.
And x squared.
So we just get x plus 11. No more root, no more 2 power. What happens on the other side? X, you got to write two of them and multiply it out. So everybody see that. Now you might wonder, well, why? Why did we make two of them on the right? We didn't make two of them on the left. Are you supposed to do the same thing on both sides? What happened?
Because you made that x squared on the other side.
The root knocked it out. The root took out the 2 power, so it didn't do its thing on the left. So there's just one of them. Does that make sense? The root took out the 2 on the left. They're opposites. So we just ended up with a single x plus 11 on the left. But on the right, we got to do two of them and multiply that out, right? First to both, second to both. And that's when the x squared will suddenly show itself. And then you go into a whole new game plan, getting a 0. And getting a 0, where do you get the 0? Opposite side of x squared. So you're going to get the 0 on the left, because the x squared will pop up on the right. So we'll go boom, 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 boom. So x squared minus x plus 1. See how the x squared suddenly showed up on the right side? So let's go ahead and gather some like terms. Minus x minus x? Minus 2x. We get to there. Now, as soon as you see that x squared, you think, oh, I know the plan. That was last night's homework. Get a 0. Where do you get the 0? Opposite side of x squared. So if x squared's on the right side, which it is, get the 0 over here on the left. Always get the 0 opposite of x squared. So, okay, so I need to get 0 on the left? Yes. How do we get 0 on the left? That means if we want to make that left side 0, get rid of both those guys, huh? Do the opposite of both those guys. So whatever you do to one side, got to keep the balance, right? That makes sense? So keep rolling. Okay, so so over here on the right side, we've got x squared. Now right here, minus 6, this is a 1, right? Just think money. We all deal with money, so you're good with money numbers. This is like a $2 loss and a $1 loss. You lose $2 and lose one more dollar, you lost $3, right? So negative 3x. And if you gained $1 and then lost $11, your bank account's down 10. Is that good? Makes sense? All right. And now we do the parentheses. We try to. So step 1, get a 0. I'm in a whole new mode now. I'm in the x squared x mode. Step 1, get a 0. Step 2, try to factor. So we can factor. So what multiplies to be 10? What times what is 10? 5 times 2. 5 times 2. And how can they make the middle negative 3? Sign in the middle goes on the bigger number. Remember that? Sign in the middle goes on the bigger. And then the smaller number can be plus or minus depending on what makes the middle correct. So think about money. If you lose $5, what do you got to do over here to be negative 3 overall? You got to gain back 2, don't you? If you lose $5 and gain back 2, you lost 3 overall. Is that making sense?
Some of them, they make you put both the positive and the 5 on the homework.
Do what's that?
They make you put both of them, the positive and the negative.
Then, yeah, it has to be in the correct.
Yeah, they make
So remember what we do next?
Oh, I'm silly. Yeah.
We're not done, right? What do you do? We still have two things multiplying to be 0. If two things are timesing to be 0,
I forgot. Yeah.
either one can be 0. So we have one more step. Remember how they always end up opposite sign that they were in the parentheses?
Yeah.
You can just jump there if you want to. It's going to be positive 5 and negative 2. But I'll show it formally. The first one is 0, or the second one is 0. That's logical, right? Because if two things are timesing to be 0, either one could be 0. And then see how it's going to just switch signs. And if you want to skip that step, feel free. You know, it's just always going to be the opposite sign that it was in the parentheses. Yeah, no, that's how you realized all that, yeah. So yeah, that's what it's going to be positive, which is what the quadratic formula will tell you. Negative 2 on both sides, negative 2. There we go. I would try factoring first, just in the overall scheme. Try factoring. If it's an easy factoring one, that'll save you time. It's quicker than the quad. Now, if it's a hard one, definitely go to the quad. If you start, basically, here's what I would suggest. With x squared equations, get a 0, and then try it. Give a second. Give like 10 seconds to the parenthesis factoring. And if you can't see it, or it's just not coming together after 10 seconds, jump into the quad. But if you can see it in 10 seconds, that'll be quicker for you.
What were your ABC on your
Nope, I still got the same thing.
What were your, where you go 10 over 2?
Now this one's going to be awful. Does that sound encouraging?
No.
This is going to be the hardest one in the section. Why he's the hardest is he's a double rooter. And there's another double rooter that's easier. He's a hard double rooter. He's a double rooter with adding. It's going to be awful. We're going to end up doing parentheses squared twice throughout the problem.
Oh, lovely.
Yeah, because it's a double rooter. It's a really bad one.
Surprise, man.
All right, so you know the game plan. What's the plan? What is the root plan?
Get it alone.
Step 1, root alone. Step 2, parenthesis 2 power, parenthesis 2 power, right? Now, this root, is he alone on his side?
Yeah.
He is.
Yeah. What about this guy?
No.
Uh-oh.
Yeah.
We're supposed to get the root alone. He's not alone. What should we do? He's with a 2.
Now,
Should we subtract 2?
should you slide that other root to the other side and give them both alone on one side?
It's a funny statement you just made. Think about what you just said. Get them both alone? If they're both there, are they alone?
No, but they're both roots.
But they're not alone. So my point in this, you're right on, there's no way to get them all alone. That's the first point I want to make. We have 3 items and only 2 sides. Not everybody's going to be alone. Right? That's why this is going to be an awful problem. Because we're really not able to get all the roots alone. There's no way to do it. And that's going to make us wish we could, but we can't. So we just have to work with what we've got. So we just go forward. One of the roots is alone. The other is not. It's best we can do. There's 3 terms, only 2 sides. That's all we can do. So let's just dive into the power thing right now. So parenthesis 2 power. Parenthesis 2 power. Right?
Why don't you just do 3? Why does it?
Yeah, really good question. The mistake that a lot of people make is they think you can do that. They think this. That's a great question. They think just put the 2 there, 2 there, 2 there. That'd be way easier. It would be way easier, and it would be way false and not true. But it'd be fairy tale mathematics. But it would
We
be.
use odds.
It's just not true. Let me prove real quick it's not true. I'll just prove it to you with numbers. Think about like 2 plus 3, for example. If you have 2 plus 3 with a square on it, is that the same as squaring that guy individually and that guy individually? No, you can see it's not, because this would be 4 plus 9. This would be 13. And this is really what? 5 squared, which is what? 25, not 13. See how that's a different thing altogether. To square a whole set of 2 things is not the same as to square them individually. So it's not the same. We can see that number-wise. And so you can't do it. It's a good question. It's important to know that you cannot do that. It's not true. It's just simply not true. So all you can do is do parenthesis 1 square on the left, parenthesis 1 square on the right. I'm doing exactly the same thing to both sides, aren't I? All right. Let's crank it out. Now, on the right, let's start with the right side because he's the easy side. On the right side, the root is over the entire right side, isn't it? He's the one we got alone, or was alone already. Him and the 2 power are just going to cancel, aren't they? So that's a piece of cake, right? That's just x plus 13. No more root, no more 2 power, piece of cake. But on the other side, no cake. On the other side, we have to write 2 of them. Like that. Right? Why? You might think, why? Why can't we just bring down the 2? It's because of that plus sign. Remember Costco glue? These are 2 terms glued together. Package deal. You can't bring down that 2 and just do them individually as we just showed. You have to write 2 of the parentheses, and then you've got a foil like this. Does that make sense? First to both, second to both. It's going to be a big mess. Now, what's root x times root x? Plain x, right? Because 2 in, 1 out, right? Plus, and what's root x times 2? 2 root x. Remember, the 2 goes to the outside? Outsiders stay outside, insiders stay inside. No crossing the lines like jail, right? And then this 2 goes to both.
Which would be the same thing.
Same thing. 2 stays on the outside, x stays inside, and then finally 2 times 2, 4. We good there so far? Can we gather some like terms?
Yes.
Yes.
2 root x and 2 root x?
4 root x.
Yeah, you just add the numbers in front. They're just like terms. Okay. Now, it's easy at this point to almost feel like giving up. Like, it's still pretty messy. I don't even know what I'm doing. Where are we supposed to do now? We're getting nowhere.
Oh, that's funny. Then you bring that X and the 13 over.
It's true. And here's, oh, no, not them. No, the other way. Here's what should lead your thoughts. Look back here. We have two game plans, right? We have a game plan if we ever see a root. We have a game plan if we see x squared and x to the first. Let's look back at our problem. You tell me which of those two we see. Do we see a root or do we see an x squared and x to the first? What do we see? An x squared? Do we see an x squared anywhere? No.
No, but you can make.
Do we see a root? Yeah, you could make one. We don't want to do that. Do we see a root anywhere?
You do see it.
Yes, indeed. He's like calling out, hey,
I want to be able to.
I'm a root. And what do we do with the root? What's the root plan?
I want to make that.
Get him alone. That's what we're doing. That's what needs to occur to you. That thought needs to drive. You need to be crystal clear focused on the fact that if any root pops up, you get him alone and 2-power him, right? That's always the plan. So all of our focus changes. We think, oh, it's a root. Get him alone. Get him alone, and then we'll 2-power. So we're moving now to get him alone. How are we going to get this root piece alone?
Put the top on.
We got to get rid of this x, and we got to get rid of that 4. And what do we do to one side? You got no choice but to do the same thing to the other side. These cancel. And we get 4 root x. These cancel. These cancel. 13 minus 4 is 9. We're almost there. One more step to get that root alone, and then we'll put a 2 on
I
it.
have a quick question. Why did you just minus that? Why?
Between the 4 and the root,
Right.
there, so let's divide it off of there. Right? Divide by 4. Divide by 4. Boom. So root x is 9/4. Last step to get, now we got to get that root off there.
You got a square on both.
2-power, 2-power. The 2-power
Let's see.
cancels the x. And the other side, you just got to square the 9 and square the 4. 9 times 9?
81.
4 times 4?
16.
There it is.
Can you break it down?
No.
No, don't.
No, they don't have anything in common. How do I know so?
Never mind. Never mind.
Yeah, nothing divides into 81 and 16. I know because they came from a 9 and a 4. Nothing goes into 9 and 4. Right? The root, isolate him and 2-power him, right? Now, having said all that, I realized that I messed up the last problem. I mean, I didn't mess it up, but I didn't finish it. I just got thinking about the quadrant. But back to number 14. I don't know if you're doing your homework right now, but these answers, you type those answers in, it'll say no, and it's right. That's not right. After all that work, sorry, we're going back to 14. 14's got one mistake, and I've been leaving off the third step because I just don't want to bug you with too much stuff, but now we have to think about it. There is a third step to root problems, which we've been ignoring because we didn't need to up to now, and that is you have to check. So, when you're solving roots, first step is get it alone, then 2-power, but you do have to check. And I don't mean, it reminds me of, I remember years and years ago, my daughter that's away at Cal Poly now, sitting down to help her with some math homework, and she was doing some root problems. And I said, oh, honey, you have to check those. And she's like, oh, Dad, I know. They always say check in my little math book, but I never check. I don't bother with that. I said, oh, no, honey. It's not that kind of check. It's not the kind like, oh, you're supposed to. That'd be good of you if you did, but it's not really required. No. This method can lie to you. This method can give you false answers. It's the best thing we got. It's all we got. But you have to know this method can give you false answers. You must check. Not because you might have messed up, but because the method itself has the ability to lie to you and bring in what are called extraneous roots. I won't bug you with that or write that down. That means extra roots, extra answers, false answers. So one of these answers is actually not true. The other is true. So, sorry, we got to finish 14. So what do you got to do? So number 14, the long-awaited conclusion. So what was the square root of x plus 11? X plus 11 equals x minus 1. Okay. We have to check. And so this first one, we're going to check x is 5. So take x is positive 5 and plug it into that equation. Plug it in there and plug it in there. And make sure that it really makes the equation true, because we might be being lied to on this one. Let's see. Now, it's easy to do it. It's not hard. You can just do it on your calculator, really. Just plug in. It's just all numbers, you know. Square root of 16. What's that? 5 minus 1. What's the square root of 16? Yeah. See, it works perfectly. So that's yes. That answer is a good answer. But how about the other one? The other one's no good. We'll see it. So that one's good. That one works fine. What was the other answer? Negative 2? That one's not going to work. Let's see it. So if you check, x is negative 2. Same kind of thing. You're going to plug that negative 2 in right there and right there. And so what do you get? Square root of negative 2 plus 11 equals negative 2 minus 1. And so what do we get there? Square root of 9, that's minus 3. And what's the square root of 9? It's just 3. It's not minus 3. No, they're not equal. So the only answer to this problem is the 5. The negative 2 is a false answer, what they call, this one is, and I'll write it for you, extraneous root. I'm not into the names, but you might have a math teacher after me that mentions that. So you heard it here first. No, so I want you to not be confused if they use that word. Extraneous root, false answer. It's an extra answer. A root is another name for answer. False answer.
So in the homework, do we just put 5?
Does that make sense? So the method has the ability to lie to you. So you have to watch it. Now, why does the method lie to us? Well, it's the squaring both sides. It covers up signs. Like you could start with something that's not true. 3 equals negative 3. That's not true, is it? But if I take that and I square both sides, remember, that's the action we did. We did parentheses square, right? What will happen? What's 3 squared?
9.
What's negative 3 squared?
9.
Now it looks true. That's what it, now you think, well, I didn't say that. Well, it did it with an X, so you didn't see it happen. But that's effectively what it did to us and why it can lie to us. So it's like if you have a friend that lies regularly, you always got to watch your friend, right? I mean, that's the truth. I had a friend. Well, when you square both sides, so when there's, how about this? When it begins with a root, any problem that begins with a root, you must check your answers because you can get a false answer. So I'll remind you about that again on practice exam day. You know, because that's when so any problem that begins with a root, when you see a root, you should check your answers because you could get a false answer. All right, I'll do the best I can. There's a lot of hard ones. All right, number 16.
Are they all the same?
No, that's the problem. They're similar, but there's slight differences. All right, equals the square root of 5m plus 59.
Are they different formulas?
We'll see. All right, yeah, I'll do what I can. So, all right, so we got roots. We know the game plan. When we got roots, what are we going to do? Yeah, but again, we have 3 things with 2 sides. One of them already is by itself. That's the best we can do. We're going to go parenthesis 2 power, parenthesis 2 power, right? That's the game plan when we have roots in there. So what's going to happen now on the left side? Is there a plus sign there?
No.
Or a minus? No. So we don't have the same problem we had back here on 15. See how we had a plus? Oops. We had a plus sign there between those guys. So we had to write 2 of them, right? Because there were 2 separate things glued together with a plus sign, but 2 separate things. And so they had to separately multiply, and first to both, second to both, because there was a first and a second. But here, there's no such thing. These are one term. They're not separated by the glue. Okay, so why am I saying all that? Which makes it easy. This is easier. You just square the 2, 4, and remove the root. 6m plus 3. You don't need to write 2 of them. Over here, remove the root. Do you see that? That's different because we didn't have the plus sign or the minus in between. So when you have pluses and minuses between things, it makes them two terms, and you have to, do two of them times two of them, and that's first to both, second to both. That's more complex. But if you don't have a plus or minus, it's just one thing, just square it, square it. It's all good. Can you take it from there now? Now it's easy. Now there's no more roots. Just get the m alone. I'm looking at those hard ones. Distribute 24m plus 12. So m saying, I want to be alone. What do you do when there's m's on both sides?
Bring one on the other side.
Yeah, get rid of one of them, huh? I usually get rid of the lower one. And so 24m minus 5, what's that? 19m. And then subtract the 12. What's that? 47. Last step. Divide by 19. Boom. Now, remember I said roots you have to check? I honestly wouldn't do it. Don't waste your time in your homework. All of them, except for that one, are going to be right answers. Just that one. Was that number 14? Yeah, 14. Yeah, 14. Only 14, really, you need to check. The rest of them in the homework, the answer's right. It's good. I don't want to waste hours of your life. Check it. So, honestly, I don't think I'm going to put it on the test. I wanted to show it to you, but it's really more of a pre-calculus thing. So just being straight with you, I'm not going to put a false answer one on the test. It's a little more advanced. But I just wanted to expose you to it a little bit. So if you go to pre-calc and you see it there, that's where, when I teach pre-calc, I put them on the test.
But just know that there is a false.
There is a false answer with the root. Yeah. But I don't want to waste hours of your life. This answer's good. If you plugged it in, it would work. All the rest would work except for number 14. All right, so let's move on. There's some tricks. I'm going to skip 17 because that's the same. Let's go to 18, which is a little different. X to the fourth minus 10x squared plus 9 equals 0. Okay, this one's different because it's a big old whopping power. Fourth power. We haven't had that before. What are we going to do with a big old fourth power?
All the same principle.
Yeah, same principle with factoring, huh? Do you know what I mean? Like, what could we put in front here? What would multiply to be? Yeah, x2 and x2 would make x4, huh? Does that make sense? And then we just do the same thing we normally do as far as like, what multiplies to be 9 adds to be negative 10? What times what is 9?
9 and 1.
Yeah, 9 and 1. And what signs do they need? Sign in the middle always goes on the bigger. And the other one can be plus or minus depending on what we need. It's got to be negative also, because two negatives will multiply to be positive 9, and they'll make negative 10 in the middle, won't they? So far, so good? Now, what do you do when you have two things multiplied to equal 0? Yeah, if two things are timesing to equal 0, either one could be 0 to make that true. Remember that logic? So that means the first one could be 0, or the second one could be 0. Is that good so far? Yeah, now remember what we learned. Yeah, he wants to be alone, right? Let's just get him alone. Add that 9 to both sides. And we'll get x squared is 9. And what do we do to turn that into regular x? And what did we learn? When you put a roof on the house?
You do it plus,
up and down the ladder.
Up and down the ladder. Plus and minus, right? When you put a root on both sides, you've got to go up and down the ladder. So x is plus or minus root of 9? 3. So that's two answers. Now the other side is going to have two answers also, isn't it? Add 1 to both sides. There's going to be 4 answers. X to the fourth in the beginning, 4 answers. X squared is 1. What do we do to get rid of that 2 power? Roof on the house. Up and down the ladder. Rooting cancels squaring. Plus or square root of 1? Just 1. So we got 4 answers. 3, negative 3, 1, negative 1. So x to the fourth? 4 answers.
Oh yeah, that's what I was talking about.
Yeah, it's that one. It's because it's x to the 4th.
So you do the same principle.
Yeah, that thing looks awful, doesn't it?
Yeah, but the good news is the zeros are around the right.
Yeah, that is the good news. It's part of the good news. This one is actually not bad if you see it right. Do you know what math is really? If you ever, you probably. I was going to say again. Do you stay up late at night thinking, "What is math really?" I know that's what I do because I'm a strange math teacher. Do you know what math really is? It's the science of patterns. I've said it a couple times.
Yeah.
Math is patterns. It's getting better and better. Math ability is getting better and better at recognizing, predicting, describing patterns. It's that simple. So is science, right? All science is patterns. They notice a pattern in the human body, and then they on and on you go. All of it is patterns. That's all it is. This one is a complex pattern. Once you see it, it's cake. Let me show you. What if we had something like w squared plus 2w minus 8 equals 0? You could all factor that one, right? How would they? You put the w's in the front, right? What multiplies to be 8? 2 and 4. Sign in the middle. And the bigger. The other one has to be minus because 4 minus 2 makes plus 2 and they multiply to be minus 8. That's exactly what this is. Do you see it? This is like a big old W. And this is the exact same thing. So you could say it's W also. You see, they're trying to throw you off by giving you the same pattern but making it bigger and uglier. But it's the same. If you have eyes to see it, it's the same pattern. It's something squared plus 2 times that same thing minus 8 equals 0. It's just like the W one we just did. Okay, so what does that mean? What do we do? Well, that means we do the big old parenthesis. It's going to be a little bigger in size, but the pattern's the same. Okay, and right here, I put W and W. But in this case, I'm going to put negative 3x minus 7, negative 3x minus 7. Right? Because negative 3x minus 7 times negative 3x minus 7 is negative 3x minus 7 squared.
Okay.
Same principle, right? Treating that whole minus 3x minus 7 like it's one entity. You see how I'm looking at it that way? I'm seeing it that way? That pattern? It's the same as the W pattern. And what number? Yeah, what number's back here to multiply to be the 8? 2 and 4. How do they make? And the sign in the middle plus. Sign in the middle goes in the bigger. So minus 2 plus 4. There it is. And now we'll do more steps, but that's the major step. Does everybody see that? See how it's exactly the same thing? It's just bigger and uglier, but the pattern is identical. Being able to do that more and more is math and science ability. Recognizing patterns. All right, so now we have a big old parenthesis and a big old parenthesis. Multiplying to equal 0. You have 2 big old things timesing to be 0. What does that mean? The first one, the whole thing, is 0, or the second one, the whole thing, is 0, right? If those 2 big things are timesing to be 0, either one could be 0 to make that happen. See how we're following the same exact pattern we always do? It's just bigger. So then we just do the like terms. Minus 7 minus 2 is minus 9. Over here, minus 7 plus 4 is what? Minus 3. These two make minus 3, and these two make minus 9. And then x is saying, I want to be alone. So we add the 9. So minus 3x is 9. And then divide by the negative 3. So x is 9 divided by negative 3? Negative 3. Other side. Add 3. Minus 3x is 3. Last step to get x alone. Divide by minus 3. X is negative 1. There it is.
Okay, I would have not done that and just.
Okay. So this is big old fractions. Have we done some of these before? I'm trying to remember.
Kind of.
On the first one?
Not like that.
Okay, so So when you have fractions, all right, we need a game plan here. Fractions with an equal sign. What's the plan? Step one. Factor denoms. So if it, bless you, factor denominator. So this guy right here needs to be factored, huh? Let's factor that. Whoops, that's not the problem there. Okay, so we can factor that. That's going to factor. Any ideas how it might factor? Hint, hint, look to the left and see those other two. Yeah, it's going to be those other two. X minus 1, x plus 3, of course, huh? See how they're making these problems? They're not that creative. It's pretty obvious what they're doing, huh? See that? See how that works? That multiplies to be negative 3, adds to be plus 2. Okay, so that's step one. So we did that. Step two. LCD over 1 to all terms. And what is the LCD? Yeah, one of each. Yeah. Well, so I'm going to do the whole. So x minus 1, x plus 3. X minus 1, x plus 3. X minus 1, x plus 3. Everybody see that? So you multiply the whole, that's LCD over 1. You know, I don't got room to write over 1. But anyway, it's the LCD, and the LCD is one of each type, one of each. And then step 3, cross cancel. And multiply the leftovers. So x minus 1 cancels x minus 1. What's left over there? X plus 3 times x plus 1, huh? Everybody see that? And then in the middle, x plus 3 cancels x plus 3. And we have minus 4 times x minus 1. Plus, don't forget that plus sign in the middle there. And then these both cancel, don't they? It's just 8. That's nice. Okay, let me pause there for a minute. Does everybody see what happened? Is that good? Now we have to multiply this stuff out. So we're going to get x squared plus 1x plus 3x plus 3. And here the minus 4 distributes. Minus 4x plus 4 plus 8. Try to keep the equals right there. Are you still with me? Let's gather some like terms. These two. So x squared plus 4x plus 3 minus 4x plus 12. Especially these two sections, you want to have super clear in your mind two game plans. If a root shows up, get it alone 2 power. We don't have any of those. And if a 2 power shows up, what was the plan? Let's go back. Get a 0. Try to factor. If it won't factor, do the quad. So you want to be super clear on those two recipes. Does that make sense? If a root shows up, get it alone 2 power. If an x squared shows up, get a 0, try to factor. So notice it's very different. Like Dennis was saying early on tonight. For x squared, we have to get 0. For root, we don't get a 0. We just get it alone in 2 power. But for x squared, our first thing is to get a 0. It's to get a 0. So we have to be keen on those when those show up. And x squared has just reared its ugly head. It's like we were just out rowing our boat on the lake, and all of a sudden the sea monster just reared its ugly head. There it is. But we know what to do. As soon as we see that x squared, we say, oh, there's the sea monster. Get a 0. Get a 0. On the opposite side from x squared, right? So x squared and x to the first just showed up. Step 1. Get a 0. So where am I going to get the 0? Where's the x squared? The x squared's on the left, so where am I going to get 0? On the right. So how am I going to get, I'm going to make this right side 0. How am I going to make that right side 0? Opposite and opposite. And those are gone, and it's 0. And whatever you do to one side, you got to do the same thing to the other, right? So plus 4x and minus 12. So we get x squared plus 8x minus 9. So get a 0. Step 2, try to factor. That's worth 10 seconds of looking at it because it'll save you time. It's easier than the quad if it factors quick. So what two numbers multiply to be 9? 9 and 1. What sign? Sign in the middle is plus. So the bigger one's plus. The other one can be plus or minus depending on what you need. What do we need? Negative, because 9 minus 1 will make 8 in the middle, huh? No, we're not done there. Remember, it's always opposite sign of what's in the parentheses. Can I just jump to it and say it's minus 9 and plus 1, and we're done? Remember how it's always opposite? Does that bug you? I don't need to skip. I can.
You can, that's what I do.
Is it okay? Does it bug you if I'm skipping that step? You just set each one to 0 right, then it ends up being opposite sign when you move it over. Minus 9 and plus 1. So that was kind of a pretty long one. A lot of mess to it. This section has a lot of these.
So the plan is, so this section pretty much you're using all the formulas we used in 2, 3, 4, 5.
Yeah, that's true, huh? There's just a lot in this section. 6 over x, so no more fractions here. 6 over x equals 9 over 3x plus 9.
And the square roots of that. Yeah, get to those.
All right. So, again, you're thinking fractions with an equal sign, right? So,
Yeah, LCDs and stuff.
yep. So whenever you see fractions with an equal sign, you know the plan. Step 1, it factor denominators, but we don't have any denominators that need to be factored this time. Step 2, LCD over 1 to all the terms. And what is the LCD? Right, LCD is 1 of each. So yeah, 3 and x, you don't need the other x, just 3x. So you know what, so take it from there. It's going to be 3x over 1, 3x over 1, 3x over 1. Step 3, cross cancel. Multiply leftovers. How you doing there? Is this going okay? All right, so how are we doing? So canceling the x's. So those x's cancel. What's left over there? 3 times 6. 3x cancels. What's left over? 9. Here, 9 times 3x, because nothing cancels. Is everybody seeing that? Seeing what I did there? So I'm cross-canceling. So be real careful on your cross-canceling. To cancel out what you can. See how the x's cancel? And the 3 and the 6 are left? It's going to be 18 in a second. You can make it 18 right away if you want. In the middle, the whole 3x canceled, and it's just the 9. And then on the right, nothing cancels. Remember, you think, why does the 3 go in there? Well, it's only top to bottom. You only diagonally cancel. They're both in the top. They're just going to multiply. See the difference? You only cancel top to bottom, huh? So that'll be 18, 9, 27x. We're good to there? Now, x is saying what? I want to be alone. So who do we need to get rid of if x is going to be alone? The 9 first. And so 18 minus 9 is 9. And now who do we need? X still saying I want to be alone, so who do we got to get rid of? The 27. Now, yeah, you can't leave 9 over 27 because they're both divisible by 9. Divide by 9, divide by 9, 1/3. Yeah. That make sense? We good there? Questions on that? All right. I'm going to leave.